Okay, so here we've got gas in a piston cylinder, and it undergoes three processes. First is constant volume, then another compression where PV is constant, P times V is constant, and then a constant pressure process. So for that first process with constant volume, right, so the change in volume from 1 to 2 is 0, right? Remember that my work is defined as the integral of P dV. Okay, so if the change in volume dV is 0, then the work from 1 to 2 is 0. So just remember, anytime you have a constant volume process, that is no work occurring. Now for the second process, again, work, this would be 2 to 3. Again, we have the integral of P dV. Now, here's the thing. My pressure equals that constant divided by V. So I'll go ahead and put that in there. So that's going to be the integral of the constant divided by V dV. Well, clearly, my constant can come out, and all I'm left with is 1 over V times dV. Well, the integral of 1 over V is actually the natural log. So what this equals is that constant times the natural log of V3 over V2, okay? Where that constant is essentially P times V, okay? And what I know here is that I know P2 and V2 because this is constant volume, so V1 equals V2, P2 is given to me. So I'm going to take this as P2 times V2 times the natural log of V3 over V2. So that's going to equal P2, which is 2 bars, so I'm going to say 2 times 10 to the 5th. V2 is for cubic meters, so what I'm going to be left with is a Newton meter, which is a joule. Okay, so take that times 4, times the natural log of V3 over V2, which is going to make that dimensionless. So V3 is 2, V4 is, V3 is, V2 is 4. I think I did that. Yeah, that's right. Sorry. And what I get when I calculate all of that is 554,500 negative, and that'll be joules, which I can easily write as negative 554.5 kilojoules. Okay. Negative sign means that it's work being done on the system, not work that's being done by the system. Okay. Moving to the final one with the constant pressure, that's work 3 to 4. Well, that's going to be, again, the integral of P dV. Now, here's the thing. Pressure is now constant. It means I can pull the pressure out in front right there. Okay. Pulling that pressure out in front, that pressure is going to be, let me see here. Do I have that final pressure? I guess I 4. Okay, well, I guess I get that from this very first situation, right? Where, again, I'll come up here and I'll say P2V2 equals P3V3, right? Therefore, P3, which is equal to P4, is P2 divided by V2 over V3, which is going to give me a pressure of 4 bar. Okay, so taking that 4, plugging it in up here, so that's 4 times 10 to the 5th times, that would be V4 minus V3, which is going to equal 1 minus 2. Okay, and what that gives me is a negative 400 kilojoules. Again, negative means work being done on my system. Kilojoules, this actually gives me 400,000 as an answer, but I just kind of skipped that step like I did up above there. So again, constant volume is no work. Constant pressure, the pressure comes out of the integral, and then when I have this polytropic process where P times V is constant, I can pull that constant out, have 1 over V, get that natural log, and put it in there like so.